Now that we've taken a look at rewriting some formulas, let's go ahead and use some formulas to solve some problems. We're starting with a situation where a couple inherited $10,000 and they want to save all of that money in an account that pays 5% interest compounded annually, or I'm sorry, not annually, quarterly, compounded quarterly, to help their daughter go to college in 3 years. We want to answer two questions here. We want to know how much interest is going to be earned in that time and how much money will be in the account at that time. We're going to use the compound interest formula in order to evaluate that. So this formula is very common in finance, and all the banks will use this formula essentially to figure out how much interest is going to be earned over time. So let's break down the parts of the formula. The first part is A. A represents the amount in the account after T years. So that's going to be our total after money has been earned. Principal is the invested amount, so our starting amount of money. T represents time in years, and that's very important. If they ever give us a value that's not in years, it must be converted to years, such as 24 months as 2 years or a decade as 10. R represents the annual rate of interest, and that's going to be written as a decimal. It needs to be in decimal notation. And then lastly, we have N, which represents compounding frequency, which is how often interest is accruing and being added to the account. And so there's some common terms that we'll see for compounding frequency. The number of times a year that is being accrued. If it's annually, that's 1 time per year. 1 time per year. Semi-annually is 2 times per year. Quarterly is 4 times per year. Monthly is 12. Weekly is 52. And daily is 365 days per year. So looking at our problem, we can go ahead and figure out what values we know and which ones we need to solve for. Well, since we're solving for the amount, that's the thing we don't know. We're going to leave that as A. The principal that was invested was the $10,000. They said they're going to invest it for 3 years, and the rate of return is 5%, which in decimal notation will be 0.05. Compounding frequency was listed to be quarterly, so it's going to be 4 times per year. So we can take these values and we just substitute them into our formula. A equals 10,000 times 1 plus the interest rate divided by the compounding frequency raised to the power of the frequency times the time. And so what we can do is work through this problem, and we can solve it piece by piece, or if we're very careful, we can evaluate it in our calculator all at one go. So let's just do piece by piece in case we're using a scientific calculator and not a graphing one. The first thing you'll want to do is evaluate your parentheses. So we'll have 1 plus 0.05 divided by 4, and that's going to give us our rate of return. So it is going to be 1.0125 as what's inside of our grouping. See, I accidentally got rid of, there we go. And then 4 times 3 gives us 12, so our exponent's now 12. And then we can go ahead and take that number, 1.0125, and we can raise it to the power of 12. And we get this long number, so A equals 10,000. And then 1.160754518. Now we don't need to rewrite that because in our calculator, if we take the previous value and click times, you see how it's listing our answer times. That's taking the previous value in our answer, and we can go ahead and multiply it by 10,000 to get this number shown here. And since we're dealing with money, we always want to round to 2 decimal places unless otherwise specified. And since they did not tell us any rounding value, we're going to round to 2 decimal places. So the amount in the account after 3 years is $11,607.55. Now we also wanted to figure out how much money was earned in interest, how much interest was earned. Well, if we started with $10,000 and we ended with $11,607.55, if we find the difference between the two, then that will give us the amount of interest. So we go ahead and subtract the $10,000 principal, and we earned $1,607.55 in interest. So our total and the interest earned. Now let's take a look at the next example, and it extends on this. The same couple, so everything that we had above, is going to invest more money to help their daughter go to college. How much money would they need to invest so that there is $15,000 in the account after 3 years? And so what this has done is said, okay, this is the new total that we want, and we want to solve for what does the new principal need to be so that this amount is going to be higher than what it was originally. And so we'll start with the same assumptions, but now we have $15,000 as the desired amount, and the principal is what we're trying to solve for. If we're using the same bank as before, the rate will be the same as 0.5. The compounding frequency is still going to be quarterly, and the time is still going to be 3 years. And so how we write our formula will be slightly different. Now it's going to be $15,000 equals P times 1 plus 0.05 divided by 4 to the power of 4 times 3. Now we know from before that when we simplified this part, we ended up with this value up here. And so we can actually go ahead and rewrite our equation as 15,000 equals P times 1.0125 to the power of 12. Now, if we go ahead and evaluate that, 1.025 to the power of 12, we see that we're going to have this decimal number. We can write that down if we want, but we actually have a little bit more of a clever trick. If we're solving for P, well, what we have to do to undo that multiplication is divide by this rate along with the exponent. So this factor divided by this factor on both sides, 1.0125 to the power of 12. And so we can divide those. So in order to get P, all we have to do is evaluate 15,000 divided by 1.0125 to the 12th power. 15,000 divided by, let's make sure that we don't mess this up, so we'll use some parentheses, to the power of 12. And then we get a principal amount of $12,922.63. Now I do want to go back real quick because I forgot to show you. If we wanted to evaluate this whole equation at one time, we can do that in our TI-84. We can write the principal amount of 10,000 and multiply it by 1 plus our fraction, 0.05, divided by 4. I don't know where the 4 went there, as our compounding frequency. Close off the parentheses, and then our exponent of 4 times 3. And so now we have the whole equation, and we see how we get the same value that we did before in our account. We are able to evaluate it in one step. Now, last question I want to show you guys is this distance formula. The fastest average speed by a cyclist across the continental United States is 16.42 miles per hour by Christoph Stasser. If he traveled a total distance of 3,020 miles at this speed, find his time cycling. Write the time in days, hours, and minutes using the formula D equals RT. So they give us the formula, D equals RT, and we need to think about what do we know. Well, D equals distance, and they give us a distance of 3,020 miles. R equals rate or speed. Rate or speed, and they give us a speed of 16.42 miles per hour. And then there's T represents time. Well, they said find his time. So that's the thing that we don't know and what we will be solving for. So using the formula D equals RT, we can plug in the distance, 3,020, equals 16.42 times T. If we divide both sides of our equation by 16.42, then we get a time, 20 divided by 16.42, of 183.922046 equals T. Now, note that because our rate is in miles per hour, this value of time is given in hours. Now the question said, let's go ahead and write the time in days, hours, and minutes. So we need to convert this long number into days, hours, and minutes. Okay, so let's look at some things. Well, we've got, first of all, let's kind of split this and think about how we have 183 hours and we have 0.922, and that should be enough decimal places, hours. So what we have is a whole number of hours and we have a partial number of hours. Well, a partial number of hours is where we're going to get our minutes. That's where we're going to get our minutes. While the whole number of hours is where we're going to get our days, and then anything that's left over will be our hours. So we're going to be using the two different parts, the whole and the part, in order to do our conversion. Let's start with converting hours to days and hours. Now, if you've ever taken chemistry and you've done unit conversion or stoichiometry, then that skill is going to come in handy. We're starting with 183 hours. And what we want to do is we want to convert our hours into days. We want to convert our hours into days. So in order for that to happen, we need to get rid of the unit hours. So we need to have this relationship where we have hours on top and hours on bottom. And then we want to think about the conversion. Well, within one day, there are 24 hours. And so what we can do is treat this dimensional analysis as multiplication of fractions. We multiply the numerators, we multiply the denominators, and then we simplify the fraction. So if we do this multiplication, we get 183, and the hour units cancel out. So we have 183 days divided by 24. And so we can go ahead and take the 183 divided by 24, and that gives us 7.625 days. Well, we're going to keep the whole number. We have 7 days, and then the 0.625 is kind of the leftovers. And so there's a couple ways that we can look at it. We can go ahead and we can convert the 0.625 days back into hours, or we could also look at, well, how many hours is 7 days, and subtract that to see how many hours we have left over. If we take our 183 hours and we subtract 7 days worth of hours, that'll give us how many hours are left over. So 183 minus 7 days of 24 hours, and that gives us 15 hours left over. So far we have 7 days, and 15 hours. Now we just need to figure out about the minutes. So now we have partial minutes, 0.922 hours, and I want to convert that into minutes. I need my hours to cancel out. And so now we have to think about the unit rate, the unit conversion. Well, within 1 hour, we have 60 minutes. So all I have to do is multiply these values, 0.922 times 60 minutes, and we get 55.32 minutes over a denominator of 1, which doesn't really do anything. Since we don't need seconds, we can stop with the 55 minutes. We have 55. So the time it took him was 7 days, 15 hours, and 55 minutes.